Yes. All right. So we're going to wrap up some parametric. The good thing about it is it's super similar to the particle motion today. So you just have to think about it in that manner, just that there's always two components with parametric. So we already said that our velocity is given by a vector. It goes in the chevrons, and it's the derivative of position for x and y's position's derivative. That we've already talked about. We said the magnitude of it is also known as its speed, is also known as its length, and it's the square root. We did that already. Displacement also has another formula, but because you can't use a formula sheet, I want you to piggyback off what you already know about. So let's go over here. When we're talking about displacement, that's a question about position. It's about position after you've had some movement, correct? So when we did displacement in Calc 1, we'd say, well, you need to integrate the velocity from time 1 to time 2, because the antiderivative of velocity is position, and we evaluate it with our second fundamental theorem at the top and at the bottom. The difference between our positions is how far we've moved or our displacement, right? No absolute value bars. So this is really similar, except there's two components, and you have to figure out how far you were displaced both along the horizontal and along the vertical. But you'll still be integrating from time 1 to time 2. You'll still be integrating the velocity, and that'll give you the displacement along the horizontal, but you're also being pulled at the same time vertically, which is what causes all the curvature. So this one would be T1 to T2, the derivative or the velocity vector. So you really just do the antiderivative of the velocity vector on the time interval. That's really nothing new, right? Total distance traveled in rectilinear motion, or left, right, up, down, is that, right? The absolute value of velocity is actually speed, right? And our speed in here is the square root, or the length, or the magnitude of the velocity vector. So this guy right here gives you your speed. If at any time you're asked for the speed at time 2 or the speed at time 3, or if the speed is increasing, you'd have to do the derivative of this and see if it's positive or negative, those types of questions. But total distance traveled, we integrate the speed with respect to time over a specific integral. So although it looks a lot different and it looks really kind of complicated to a casual observer, you guys aren't casual observers. That should make a lot of sense to you, right? Same with your position at time t. So in Calc 1, we said that you're currently moving along the x-axis. X of 0 is equal to 3. And it would say find x of 5. Do you remember how you would do that? Do you remember? It's where you are at 3 plus your displacement, where you moved, correct? So this would be 3 plus, I'd have to figure out my displacement on the interval from 0 to what? 5 dt. Notice this right here would be x of 5 minus x of 0, which is 3. It'll give you x of 5, or your position at 5, right? It makes sense. Here, it's just going to be two components. So let's call this actually t sub 2. You would have to be told where it is at t sub 1. And it doesn't have to be at time 0. It could have said 1, and then that would just change your bottom limit, right? If this had said x of pi is 3, then it just changes your bottom limit. It's where you are at that time plus your displacement over that time interval. And then you don't even need to memorize anything because it makes sense. It's where are you at the first time given. Maybe you're at 0. Maybe you're already 3 to the right. And then you get displaced. Well, what's my displacement? There it is, right? I would take, and I write x prime of t. Some books or professors will write v sub 1 of t for the first velocity component. So I'll show you that on the next page. I don't like being tied to my notation, but I kind of like this guy because its antiderivative is x of t. It's x of t2 minus x of t1. Those would cancel, and I get x of t2. So you go ahead and write the second part, not because you're memorizing formulas, but because you just get it. Because by the time we're done, we're going to have so many formulas. So what would the second component be for the position at any time t sub 2? What are you writing down, Linz?
Y t sub 1 plus the integral from t1 to t2 y prime.
Yes. And then dt. Perfect. Not because she's got it memorized, she's never even seen it before. That's why I said if you guys understand particle motion, this chapter's smooth. It's more depth to it, but it's basically the same stuff. All right, just double the work because there's 2 components. So let's have you guys go to part A. Find the acceleration at t equals 2. Now you have to make sure what level you're on. Do they give me position? Sometimes they do. Velocity? Sometimes they do. Rarely do they give you acceleration. To be honest, for the College Board FRQs, you're most often given the velocity. So find the acceleration at t equals 3. Start with that one. That you should know that's not new. You need your acceleration vector, right? So that would be e to the t minus 1 and then e to the t plus 1. Nice, easy derivative. And then what are you going to put in for it? 3. So yeah, so it's just e cubed minus 1 in chevrons and then e cubed plus 1. What if I asked you for the magnitude of the velocity vector at t equals 3? What would you do? Just to make sure if you understand the magnitude of the velocity vector. How else could I phrase that? The length of the, yep, or speed. Any of that, or the norm, but you won't have that in here, but in Calc 3 you will. So if I ask you that, you'd go back to your velocity at time 3, right? Those are its lengths. Those are numbers. I don't know what e cubed is. It's between 2 cubed and 3 cubed. Somewhere in the 20s, low 20s maybe. Then you'd subtract 3, but what would you do with this? Square it, and then square it, and then add them, and then root it. It's a Pythagorean theorem on horizontal and vertical, so it doesn't need to be memorized. Next up, it says to find the position at t equals 3. So I need to go back, so that should trigger some integration. Where are you at t equals 3? Well, we've got to set it up, so it's going to be kind of long. So first of all, what was the initial position? And was that at time 0? Okay, so perfect. So I'm at 1, and then I'm going to integrate from 0 to 3. Doesn't mean the bottom's always 0. That's a common mistake. So make sure you know that this is just the time 1, whatever that might be. And then in here, I need to put my x coordinate of the velocity vector. It was e to the t, and was that one minus t? Yes? All right. So there's, and we wouldn't have a calculator for this one. You guys said it was also at 1, and I'm still going to integrate from 0 to 3. And this one was e to the t plus t, right? Yes. All right. So what I just need to do is, it looks complicated, but it's really not. It's kind of nice. 1 plus antiderivate e to the t minus t squared halves, right? From 0 to 3. I like to block that off so I know the 1's kind of on its own there. That's my notation though, but we should be pretty decent, right? And then comma, 1 plus the antiderivative of e to the t is e to the t. Be careful if it was e to the 2t, then what's its antiderivative? Careful, that's why I asked it. What half? I'm sorry. She's no longer my bestie. Just kidding. E to the t plus t squared over 2. I'm sorry. 0 to 3. Sorry, Hannah. There. So, like, you guys should totally understand what all this means. Are we good with what's going on here? And then we just plug it in, and so it looks like I'm going to get over here 1 plus, and it'll be e cubed minus 9 halves, right? And then I do minus, parentheses, top boundary in, bottom boundary in, e to the 0 is 1 minus 0. That is the first one. And if it was an FRQ, I'd leave it, right? If it was multiple choice, the ones will cancel, and it's actually e cubed minus 9 halves is the x coordinate. You guys go do the y coordinate. So I'm going to rewrite the x coordinate. Let me know if I'm going too fast, but there's a bit of, you have to finish the worksheet and do delta, and this stuff should seem really familiar. So the ones are going to cancel, I said. It looks like I have e cubed minus 9 halves for the position of the x. And then what do we get for the y? E cubed plus 9 halves? Yes. And we're nodding. And I guess it would because it's the same. Yeah. So e cubed plus 9 over 2. Those of you gone yesterday were Fridley, and who else was gone? Did you watch the notes? This might be a little, you might be a little lost. Are you a little lost? You did watch the notes? Okay, good. Because I'm going really fast for first timer. All right, so over here, this is what I just told you, okay? We're going to go look at this guy. And then one other thing, and I'm going to be done. So, first of all, you have to look at that and say, what level am I on? Am I on position, or am I on velocity, or am I on acceleration? I'm on velocity. Yeah, this is the velocity vector. You might want to write it just so you don't lose track because it's written as dx dt. You might just want to take a second. College Board in particular loves to mess with their notation on you. So keep in mind that's the same information, just written a little different. It's the same as if they had written x prime of t dt. You are on the velocity level. It's giving you both speed and direction, both x and both horizontally and vertically. So this is what's the magnitude, so that's a number or a scalar, right, of the acceleration at t equals pi. So you're going to have to go from velocity to acceleration. So for part A, we need to take a derivative, correct? My acceleration at any time t can be found by, and we'll just take the derivative, quick easy chain rule. And 6, right? So, did I do something wrong? Cosine. Yep, you're right. Sorry about that. Cosine. Good catch, Priestley.
You're no longer my bestie.
So 16 cosine 4t comma 6. I'm supposed to do it at pi. So I need to find the acceleration at pi. That would be cosine 4 pi is 1. And 16 comma 6, that's if they ask me for the acceleration vector at pi. This is the magnitude or its length or its norm, and you would have to do the square root of 16 squared plus 6 squared. 256 and 36. 292. Does 292 have a perfect square in it? I don't know and I don't care. Let's just leave it. Actually, I think there's a 4 in it. 4, 7. There's a 4 in it, but be fair if I don't. Okay. Thank you, guys. So nice. Hannah, if you want to clean that up, you go ahead. All right, there's a part B. I want you to set up B. That's kind of the new stuff. At t equals 0, the object is at 1 comma pi. Where is it at t equals pi? Complicated question if you don't pick it apart. What level are you on? Position, velocity, or acceleration for this problem? This is a position level question. So since we started with velocity, you're going to have to integrate. Yep. And there was an initial position. So just think it through. And your formulas shouldn't be memorized. You should just sort of flow into it from Calc 1. That's why when Dudley asked if he could take Calc 2 without Calc 1, I said no. It would not flow. Would it flow, guys? No.
Yeah.
I'm not saying it's not possible.
They do that.
They don't take Calc 2 without Calc 1, they combine them. So like they call it Calc BC and they do all of A, B, and BC in here. But they still start at limits. They don't start at chapter halfway. Actually, your bigger schools like Edina, Minnetonka, they do that, and then they have a calc 3. They have multivariable. Yeah. Nowhere around here does. We're actually the only one who has BC around here. But if you get to some of the bigger ones in the south, they have multi. All right, let's go set it up and see how it goes. Are you ready? You might not be quite done with it, but that's okay. All right. All right, guys. So I want to know where it is at time t equals pi. So the first thing I do is I say, well, I'm already 1 to the right. I'm not memorizing a formula. Plus, then I'm going to be displaced, right, which is my antiderivative of velocity. And then I have to look at what my time frame is. I'm going from 0 to where? 0 to pi. Yeah, and then I need to antiderivate the x-coordinate, which would be 16, not 16, sorry, which would be 4 sine 4t, was it? 4 sine 4t dt, comma, I have to use my whole screen, right? And then it says it was at pi for this y star, plus you have to antiderivate 0 to pi. Here's my next question. Is this bottom always 0? No. That's a really common mistake. Okay, they could have said at time t equals 2, and then you would still do pi plus, but you'd go 2 to pi. Yep. And then you would do, was it 16 minus 3? Yeah. Minus 3 dt. You wouldn't have a calculator for this one, so you'd be really careful, and you do 1 plus. This is u sub, and it's in your face pretty much. Who's u? 4t. Who's du? 4. The derivative of what is sine? Negative cosine. And then if it were me and I was on a test, I think I'd take the derivative of that just to make sure. The derivative of negative cosine is sine. It'd be sine 4t times 4. I'm good, and then I'd move on. So I'd watch your SIGNs on the SINs. Right? 0 to pi. And then I like to do that. That's my notation. I didn't change my limits because I went back to t. If you have cosine u, you would have to go from
0 to 4 pi.
yeah, same. You'll get the same answer. Okay. And then on this one, I'd have pi plus 6t squared, 3t squared minus 3t from 0 to pi. And I kind of like to do that. I need another chevron. Wow. It's got a lot of semantic or syntax on it that looks complicated. I don't like it. It's too much. No, just kidding. All right, let's go do it. So I have 1 plus parentheses negative cosine 4 pi. Then what? Watch your. Then what? Minus negative cosine 0, right? So watch your sign. So plus cosine 0, fold it, comma it, pi plus 3 pi squared minus 3 pi minus 0, chevron it. Back over to the left-hand side of the screen. Wow! What's negative cosine 4 pi? Negative 1. Plus 1. I'm just at 1. Oh, all that work. I only ended up at 1. And then over here, it looks like I'd be at 3 pi squared minus 2 pi. Don't lose track of what we found. That's where it is at time t equals pi. When it started at. Right? It's pretty cool. All right, last up, the next page I purposely threw on here because I screenshotted off the internet just to show you what you might see if you had a different teacher. So sometimes position's called r, so don't let that mess you up. Velocity is always called v of t. It's always dx, dt, dy, dt, or x prime of t. Speed, magnitude, same as length, same as norm, there it is. The acceleration, this one's saying it's the second derivative of position. You could say it's the first derivative of velocity. Displacement, just understand what that means. What is their V1 of t for us? What do you think that is? Just in case you see different notation. That's x prime of t. They're just saying the first component of the velocity vector, which I like to call x prime. I think it's easier to see its antiderivative as x. All right, there we go. Let's go down and just talk about a couple tricky things. Tangent lines are vertical when the denominator equals 0, because remember our dy dx is equal to dy dt over dx dt. And they're horizontal when dy dt is equal to 0 and dx dt is not. Do you remember what I said happens when they're both 0 graphically? Yeah, we have like the asteroid thing going, or like that 4-leaf clover we did on the backboard. You have cusps there. So this one last year is like one in your homework, and you can see I typed it in. It's in a whole new font because they all were asking me this one. So I'm going to go back to what I always tell you guys before we finish up the worksheet. I always say that when you are asked a question, you know everything you need to get it, even if it's a question you've never seen before. So there's one like this in the worksheet, and they've never seen one like it. So they always ask me this one. So I want you to take a look. It says a particle is moving along that curve. That's not parametric, right? That's our dy dx, our y equals, our f of x equals, correct? That's y as a function of x. And then it says parametrically what dy dt is when x is 2 and asks you to find dx dt. You have a relationship with dy dt and dx dt. It's actually already on my board, right? You know that dy dx is equal to what? Go ahead, tell me. Dy dt over dx dt. I'm supposed to be doing this when x equals 2, so I'm just sorting through the problem. When we did related rates, I used to tell you guys, it's all there somewhere. It's got to start with something you know that relates everything given. One of those numbers I already know. Which one is it? Dy dt is 5, correct? So I'm going to do a little rewrite. Dy dx when x is equal to 5. I'm just picking it apart. Is equal to 5 over, I don't know, dx dt when x is equal to 2. And this is what I'm looking for. Would you agree with me? Is there any way to get that? Yes. Right? I need y prime. Well, let's go over here and say, well, I know what y is. What's y? 12x to the negative 2. Yep, you're going to want to see the power because you know you're going to be doing dy dx, right? So my dy dx, dy dx would be negative 24 over what? X cubed. When am I doing this? When x is equal to 2. I'm just walking. I haven't done this problem for a year either, but I'm just walking through. What do I know? How are these things related? When I put in a 2, I get negative 24 over 8. So it looks like x will equal negative 3. Not x, dy dx. So now I have negative 3 equals 5 over my unknown. Correct? So what's my dx dt? Negative 5/3. Does that make sense? I'm going to repeat what I did. I had a particle moving on the rectilinear, like y equals 12 over x squared. That's actually a volcano graph. It's one of these guys. It's just going up steeper, right? And it tells me the rate that y is changing as t changes. And then I'm supposed to find dx. Well, what's the relationship? If I divide them, I get dy dx. And I can find it. Done. All right, so you guys are going to finish your worksheet. You're going to turn it in, and then you can go to Delta Math and give that a start if you want. I don't know the worksheet. Why don't you go do the one like that first, and then grab these in. Is it question 7? Yeah. Go do question 7, and don't look at the board, see if you actually get it. And then go back to 5. It looks like you have not many left. Yeah, you should maybe, like Amy's did what she's supposed to, so she should have about 10 minutes of work left on there. You all right there, Sparky? What? Oh, I gotta stop recording. Have a great weekend, Hannah Panorama. We are working on the worksheet. They're gonna turn it in. You can send me a picture. And then Delta Math is the assignment.